At resting membrane potential, there's an unequal balance of ions across the cell membrane of the axon in those neurons, and this is maintained by the sodium-potassium pump, which is sending 3 sodium ions out of the axon, out of the neuron, and bringing in 2 potassiums. And this maintains that concentration gradient on either side of this axon membrane, keeping a lot of sodium outside the axon and a lot of potassium inside. And since there's a lot more positive charges as we see outside the axon than inside the axon, we get a reading of negative 70 millivolts because there's a lot more positive ions outside the axon than there are inside. Now, when this axon receives a stimulus, a graded potential from the dendrites, some leak channels for sodium are going to open up, and some sodium is going to enter the axon. Now, if enough sodium enters, we're going to hit threshold, and when we hit threshold, some voltage-gated channels for sodium open up, and sodium starts to rush in to this axon. And as sodium rushes into this axon, it depolarizes and starts to give us that upstroke of an action potential. And as more sodium enters the axon, as more sodium voltage gates open up, more sodium is going to enter. It's a little bit of positive feedback, and we're going to completely flip the sodium concentration. There was an awful lot of it outside before. Now most of it is inside. Now at that peak of an action potential, at the very top, we're going to end up having most of our sodium come in along its concentration gradient, but our potassium is still trapped inside because it can't get out through its voltage gates. And then when we reach the peak of that action potential at the end of depolarization, that change in membrane potential causes the sodium voltage gates to snap shut, so sodium can no longer enter the axon along the concentration gradient, nor can it leave. But what's going to happen then is potassium gates will open up, and potassium is going to flow along its concentration gradient and diffuse out of the axon. And this is the repolarization phase of an action potential. Now, at the end of an action potential, we've got our ion concentrations completely flipped from where they were before. At the beginning, we had a lot of sodium outside, and now we've got a lot of sodium inside the axon. We had a lot of potassium in the axon. Now we've got a lot of potassium outside the axon, and their gates are closed, so those ions are essentially trapped. So the cell relies on the sodium-potassium pump to kick 3 sodiums out of the axon into the extracellular fluid while bringing in 2 potassium ions to reset that concentration gradient so this axon could fire another action potential. So these events operate in a cycle, and this is typically the action potential cycle.